Hello, can you hear me? Okay, and can you see my screen? Okay, so this is Jim, and here here I will arrange a series of BD3E training because there are some clients ask me to do this training when we do the VD2 series training. So in all series, I will introduce our control mode, for example, CSP, CST, CSV, and homing mode. There are about six class in total. And today first, I will start with this production introduce because some of our clients maybe didn't use EtherCAT server before, or so after this class, I think I will give you a start about our VD3E products. Our today's contents will divide into these four parts. First, I will introduce our products, and then I will show you the EtherCAT control modes and the objects, dictionary, and the fast. And last, I will introduce how to upgrade our VD3E firmware because we sometimes we may need to upgrade our firmware to solve some question or to use some new function. This is our server development timeline. You can see we have our VD3E server from last year. Here is our driver, VD3 driver. It supports from 100 watts and to 3000 watts. And this is rated torque our VD3E supports. For now, we have max to 21 max output current this model, and then we will have 30 and 40 current model. These two models are doing testing. We will have lens on. This is the appearance. Two types for now. A type is from 3A to 14A. And the B type is from 18A to 21A. Here, the appearance of our VD3 is like this one. You can see it's very similar with our VD2 type driver. There are two differences. First difference is about CN3 ports. Here, this port is changed to Type-C, not for VD2. We are using RJ45 to USB cable. This is one difference, and then we use this to connect our PC to use our ST tool. And the second difference is on the top. On the top, these two ports are changing to EtherCAT communication. And for VD2, these two are used for RS485 communication. Only these two different, and other place is same. And the VD2B type is also only CN3 and CN5, CN6 different. And after and here is the process. Is it possible to change parameters through communication? Communication, yes, you can change the parameters through communication, but not Modbus communication. We need to use EtherCAT communication to change our parameter. And in our controller, you can use PDO to mapping the parameter to your project variable, or you can use SDO to change the parameter. There are some function block in controller to change the parameters through SDO. SDO and PDO are two way to change our WED3E parameter. This is our process of our WED3. We are using TI process, TI production. Okay, TI production, yes. PDO and SDO. You can easily understand it as two different methods to change our driver parameter. SDO is similar. SDO is similar with our Modbus communication. You know, in PLC we may use RS instruction to change the slave parameter, and the SDO is similar with as what we do in Modbus communication. And the PDO is a mapping. For example, because there are a parameter table in our WED3E driver, and I will introduce it later. So with this parameter table, you can map the address of this table to your project. In project, you will create some variable, so you can map the driver parameter to this variable you created in your project. So in your project, you can change the variable value to change the parameter of our driver. Okay. Yeah, in WED3 we will have different CPU to process different function. Because, for example, this CPU, this CPU A is used to process this function. So in a words, with this better processor, our WED3 can provide faster response. And this is the sync period of our WED3. It can achieve about 125 microseconds. And these two pictures you can see with the smaller sync periods, the process will be more smooth. Yes. And here are some advantage about our WED3 driver. First is the communication is faster than Modbus. Usually we will set the sync period as, for example, 1 ms or 2 ms or 4 ms. So it means, for example, if we set the sync period as 4 ms, it means our driver will communicate with all our slave every 4 ms to update the parameter or update the control information to our driver. And second advantage is spend less and connect more, because compared with post control, for example, for 3V, we can connect max to 4 driver, and for 5V we can connect max to 8 driver, because we need high-speed output terminal to control our driver. So there will be a hardware limit. But for VD3E with EtherCAT communication, we don't need high-speed output to control our driver. We use communication way to control it. So you can see our PLC, for example, 6V or 6C DB type. DB type means it can connect max to 16 driver. DB, DC, DD, and for DD type, we can connect max to 128 servo driver. So if you use 5V or 3V, it's impossible to do this. So we can see with EtherCAT, we can connect and control more driver. And then the second advantage is the welding. You can see from this picture, our welding is very easy. From our controller, there will be a EtherCAT port. We use an Ethernet cable to connect it to our first driver. On the top of VD3, there are 2 EtherCAT ports. CN5 is input, and the CN6 is output. So you can see the wiring is like this: controller to server 1, and the server 1 to server 2, and connect one by one. So there will be no many cable need to wiring. But for VD2, we need to connect post cable and the direction cable and the 24 voltage cable. There are many cable need to connect. Okay, and here for the slab ID will depend on our wiring. From this wiring, this is our slab 0, or we can call it as axis 0, and axis 1, axis 2, and one by one. So it means we don't need to set the slab ID of our driver. This is different with Modbus communication. And the last is standard control mode, because there are open can open standard to define some control modes based on EtherCAT. So okay, we can introduce the control mode later. Or part 2. Here is the control mode support in VD3. Here have 4 parts. For position control, we have 2 modes: CSP mode and PP mode. For speed control, we have CSV mode, PV mode, and torque, we have CST mode, PT mode, and also we have HF mode. HF means homing mode. So here, the difference between this cycle sync position and this profile position, these 2 difference. For CSP, it means our controller, for example, our 6V or 6V or 6D will send the target position to our driver, to our VD3E in every sync period. So for example, where's my pen? Okay. So it means, for example, our target position is maybe 100, and the target speed maybe for example 200 RPM. And then the curve may be like this one. So in CSP mode, every for example, if we set our sync pair rate as this 4 ms, our controller will calculate the target position according to the current position of our driver every 4 ms, and send the next target position and the next speed, target speed to our driver. So it will control our driver to achieve our target position every 4 ms. But for PT, it means at the first of the beginning, our controller will send this to target position and target speed, and also maybe acceleration, deceleration, and the jack, and also some other control parameter. Send all the parameter to our driver, and the driver will calculate itself and to achieve the target position. So it means PLC will only send this target parameter to driver and the first of beginning, and the driver will itself to achieve the target position. This is we call PP, and the CSP PV and the CSV PV CST PT is same. For homing modes, there are 35 homing modes support in VD3E. So in our controller, usually we send the homing modes and homing speed to our driver, and the driver will begin to search in the home position, search in the 0 position itself, and finally stop and home position, and finish with our homing operation. For example, here we can check our menu. You can see this is homing mode 1. If we execute these homing modes, our driver will begin to rotate in reverse direction, and when it achieves our reverse limit, it will change its direction to forward, and finally stop and first the signal, and then take this position as the home position, and clean the current position, set the current position as 0, and finish with our homing operation. You can see here are many different homing modes. Okay. And here in part 3, I will introduce object dictionary of our VD3, how to connect the limit sensor signal with the home of the servo. We connect the limit switch signal to DI of our driver. It is connect to driver, not connect to controller, not connect to PLC. And yes, and I will also have another class to introduce our homing modes in next weeks or next, yes. What's object dictionary? As I said, there are a parameter table like this one in our VD3E. And this object dictionary is used to describe the parameter of our driver. Yes, if you understand it easily, you can just like this. And also we code because we also always say we need to upgrade the XML of our driver. The XML file is also we call it as ETS file. This file is used to describe all parameter of our servo driver, and this table is for you can see this range from 0, 0 to 0 FFF is used to describe the data type. And here also here for 2000 to 5 FFF, this area parameter is used to describe the customer customer area means this area is different brand driver. This part will be different for WECON. Okay, I will show it later. But for other parts, for this part is same. I mean, for different brand driver, they will have same address table of these two parts. So that's why we can use different EtherCAT master to control different EtherCAT slave. We don't need to use same brands because the standard the parameter is a standard parameter. Okay. Here, this is our area 1. This area is used to describe some communication parameter. For example, 1000 means a device type, and also some other parameter like this. And the second parameter area is difference according to the different brand driver. For WECON driver, we define this 2004 as our rotate direction, but maybe for other driver, their 2004 may be another parameter. So this part is different. And here 6000 to 6 FFF, this area is a standard area. So it means for all EtherCAT driver 6040, this parameter are all control board. And they are this is just a part of this area. And you can check it in our WECON support center. Here, object dictionary. You have all parameters. Okay. So here, for example, for CSP control, usually we need to import we need to input this parameter. For example, servo control mode and the target position and the target velocity, and here a dual ratio. And then the output of this CSP mode will usually, for example, actual position, actual speed, actual torque. And this is for homing mode. For homing mode, we usually need to set the check. The homing mode, we usually need to set the homing mode we select and the homing speed. Okay. And for different control mode, we have a different list control diagram. Okay, and the last I will introduce how to upgrade our firmware. There are two steps. First step is we need to upgrade the firmware first. You can download the firmware from WECON Support Center. You can find it in here, Servo, and download software. And the bottom you can see this is what you need to download. And here, second step is to connect driver to our PC by Type-C cable, and open the upgrade firmware tool, upgrade list, and open our port. And finally, click upgrade all in one. Click this one, and when you finish it, you can see in status here, it will tell you to repower your driver. So you can repower your driver. And last, you can check this parameter U2 and 4 to confirm whether you upgrade successfully or not. Okay, this is the first step. We need to upgrade our firmware. And the second step is to we need to upgrade the EEPROM of our driver, or we can also say we need to upgrade the EDS file of our driver. What's EDS? EDS is here, this one, electric data sheet. So how to do? First, we need to download this EEPROM programmer, and you can also download it from our WECON Support Center. And second step, you need to connect driver to PC. Use Ethernet cable, and in driver side, please connect CN5. Don't connect CN6. And here, open our XML file. This XML file, you can also download it from WECON Support Center. This yes. And here, click scan and program the selected driver. And let's all these two parts. Here, please note it. The servo firmware and the servo EEPROM EDS should be same. For example, you upgrade the firmware to 1.11, then the XML should be also 1.11. So usually we need to do these two steps together. Okay, let's our today's content. And in our from next week, every Tuesday and Thursday, we will have VD3E training. And the next Tuesday is about CSP control mode, and then CSV control mode, CST control mode, homing mode, and torch pop. So we have 6 class in total.